Software testing is vital in software development. It ensures that the software we use works as expected. Quality assurance, or QA, is a big part of this. QA focuses on preventing defects and maintaining software quality. Testing is a key part of QA. It involves running the software to find any problems or bugs. There are many different types of software testing. Each type has its own strengths in finding specific kinds of problems. One such testing technique is boundary value analysis, or BVA. Software testing ensures that the software we use is reliable and does what it should. It helps deliver a better user experience. QA, through testing, plays a crucial role in the success of any software project. Boundary value analysis, or BVA, is a software testing technique. It focuses on the boundaries of input values. It checks what happens at the edges of these boundaries. Imagine a text box that asks for your age. It might have a limit of 3 digits. BVA would test what happens when you enter 000, 001, 099, 100, 999, and 1000. These are the boundary values. BVA is based on the idea that errors are more likely to occur at these boundary points. This is where the software's behavior might change unexpectedly. BVA is a black box testing technique. It means you don't need to know the internal workings of the software to use it. You only need to know the valid and invalid input ranges. Why is BVA so important in software testing? It's simple. BVA helps us find a common type of software error. These errors occur at the edges of input ranges. These errors can cause the software to crash or produce incorrect results. For example, imagine a program that calculates discounts. A user enters their purchase amount. The program then calculates a discount based on that amount. A boundary value error might occur if the program doesn't handle amounts at the very edge of a discount tier. This could result in the customer getting a larger or smaller discount than they should. BVA is especially important when testing for security vulnerabilities. Attackers often target input fields with boundary values. They try to exploit weaknesses in the software's input validation. By using BVA, we can identify and fix these errors early in the development process. This helps us improve the quality and security of our software. It also reduces the risk of costly errors in production. Section 4. How to perform boundary value analysis. Performing BVA is a straightforward process. Here are the steps. 1. First, list all the input variables for the functionality you are testing. These are things like text fields, drop-downs, or checkboxes where the user can enter data. 2. For each input variable, identify the valid and invalid input ranges. For example, a text field for age might have a valid range of 18 to 100. 3. Choose test cases that cover the boundary values. These include the minimum and maximum values as well as values just below and above the boundaries. So, for the age field, you would test 17, 18, 19, 99, 100, and 101. 4. Run the test cases and observe the software's behavior. 5. Check if the software behaves as expected at the boundary values. If not, report any defects found. Remember, the goal of BVA is to find errors at the boundaries. By carefully selecting test cases, you can increase the chances of finding these critical errors.